Hello and welcome to this introduction to evolution video. I'm Dr. Aled Roberts, and in this video we're going to look at evolution theory and how it developed based on our observations of the natural world. And so I guess one of the first questions we must ask ourselves is, what is evolution? Well, essentially it is a biological process by which living organisms change and adapt to their surroundings over time. And because the Earth has a vast range of different habitats, evolution has led to the rich diversity of life we see today, all the way from the small single-celled bacteria up to the largest animal, the great blue whale. Now, one thing we will look at through this series of videos is how organisms become suited to their surroundings and how some species share certain characteristics whilst others have developed their own characteristics. And so we're going to go on a little journey and look at how the theory of evolution came to pass. And it all started around 350 BC when Aristotle, one of the most famous Greek philosophers, suggested that all life forms are as designed by God, remaining unchanged from the time they were created, and this is fitting of his creationist point of view and the ideas put forward by the Old Testament surrounding creationism. Now, through his observations of life, he concluded that there was a scale of nature, better known as the scala naturae, whereby all living organisms can be ranked hierarchically from the inorganic at the very bottom of the scale all the way up to humans and angels at the top, and it's best symbolized by a ladder, whereby each organism has its own step on the ladder, and each step is in order from bottom to top in terms of both importance and complexity. Now, over time, many scientists noted that all life forms are suited for life in the environment in which they live. So land mammals, for instance, have some form of feet so that they can walk on land, whilst aquatic mammals have some form of fins to help them swim in the ocean. And amongst the creationists out there, these life forms were suited to this particular environment because it was God's design. Now, if we were to fast forward over 2,000 years later to the 1750s, a Swedish physician and botanist known as Carl Linnaeus set about sorting living organisms into groups based on shared observable characteristics. And essentially this sparked the development of what we call Linnaean hierarchy, whereby species were grouped together into increasingly inclusive groups that had more and more shared characteristics. Now, in order to make sense of these groups, Linnaeus developed what we call a binomial naming system, whereby each species was given a two-part name, one relating to its genus and the other relating to its species. And essentially the genus is a large group that contains a number of related but different smaller groups known as a species, all of which share some similarities but have distinct differences. Now, a good example of this naming system is for the modern human, or more specifically the Homo sapien, whereby Homo is the genus name with sapien designating the species. Now, there are other species grouped within the Homo genus, such as Homo habilis and Homo erectus, however both of these species are now extinct. Okay. If we fast forward to the end of the 18th century, another important aspect of evolutionary theory was unearthed by the Scottish geologist James Hutton. He was studying geological features of the landscape and noted that geological changes result from slow and continuous actions occurring at a set rate rather than sudden or erratic events. So, for example, a river is able to slowly carve its way through the landscape. Now, this essentially led to the development of a theory known as gradualism, which he then further developed into the geological principle of uniformitarianism, which is where geological changes are the result of continuous and uniform processes. Now, this way of thinking piqued the interest of a few scientists, mainly some of the creationists, and that is because if these geological processes were occurring at a set rate, then that would make the Earth a lot older than some of the biblical texts suggest, and this essentially opened the eyes of some people and set in motion a new way of thinking. Now, around the same time, the English economist by the name of Thomas Malthus approached this from a slightly different angle and published an essay on the principles of population. And so as part of this essay, he suggested that as the human race continues to grow, it will at some point outstrip its natural environment and exhaust all available resources. He then went on to suggest that we could only better ourselves as a species by limiting our overall population growth. Now, this might not seem wholly relevant in terms of evolution theory. However, Malthusian outlook got people thinking about how certain environments support life, or more importantly, how overpopulation of an environment may lead to competition of resources. And so one of the more interesting aspects of this Malthusian outlook is that it was put forward in the 1790s, when the world's population was just about to hit 1 billion. Since then, it has continued to grow, and we have since increased our population on Earth to just over 8 billion worldwide. So a key question for us as a species is, when will we reach the point that we start to outstrip supply of our limited resources? Some people might say we are already there. Now, moving on a decade or so into the early 19th century, we get our first hint at a potential mechanism for how life was changing on Earth over time. And that was due to some of the work being done by the French biologist Jean-Baptiste Lamarck. Now, unfortunately, his work is remembered for all the wrong reasons. You see, whilst he was the first to propose a mechanism for how life changes over time, it became apparent very quickly that the proposed mechanism was in fact incorrect. You see, Lamarck observed animals and their interactions with the environment around them, concluding that over time they improved themselves. So as an example, he believed a giraffe's long neck was the direct result of its stretching for leaves high up in the trees, and that this feature would be passed on to offspring via a process known as inheritance of acquired characteristics. Now, at the time, this was a relatively respectable hypothesis, as fossil records corroborated his assumptions, showing that over time the neck of a giraffe did actually grow longer, or that certain traits were lost. But that is only half the story. You see, it would take one of the most famous evolutionary biologists to set the record straight. Enter Charles Robert Darwin, an English naturalist from Shrewsbury who left the UK in order to explore the South American coastline whilst aboard the HMS Beagle. Now, during his time on this 5-year expedition between 1831 and 1836, he observed and collected information on thousands of different plant and animal species, describing their intricate details and how this allowed them to adapt to the environment in which they were found. Now, one of the more interesting observations he made was that whilst travelling between the different Galapagos Islands, he observed that some bird species were common across multiple islands, whereas others were unique to specific ones. So he started to hypothesize that organisms such as the birds he was observing had migrated from the South American mainland to the Galapagos Islands. It was then on these different islands that they started to diversify and give rise to new species. He then took this a step further and started to hypothesize that the colonization of an environment, adaptation of the organisms to that environment, and the emergence of a new species were all closely related processes. Now, his explanation for how these adaptations arose focused on natural selection, which is this process by which individuals who have certain traits that aid survival are able to reproduce more frequently due to these traits. And essentially, he identified that these adaptations could not possibly result from random mutations. Then, a little while later in the 1840s, after he returned from the Galapagos Islands, he set about putting pen to paper to write out his hypothesis. And then in 1844, he wrote an essay on descent with modification, and the underlying mechanism, natural selection. Now, this essay wasn't published, as much of the world still held a creationist point of view, and he knew there would be absolute uproar. And so he sat on it for a while, and he waited and waited for almost 15 years. Then he received the news that every researcher dreads. Someone else had identified something similar and was going to publish. And that person was Alfred Russel Wallace, a Welsh naturalist who was making the same observations as Darwin, but in the South Pacific Islands off the Malay archipelago. And so he sent his manuscript to Darwin for approval, and if approved, to pass it on to the Linnean Society of London for publishing. And so in 1858 this was published to the Linnean Society along with extracts from Darwin's unfinished paper. And this essentially prompted Darwin to complete his writing, and just a year later in 1859 he published his book called The Origin of Species. Now, the interesting thing in all of this is that despite Wallace publishing the idea of natural selection first, he admitted that Darwin had done so much extensive testing on the idea of natural selection that he should be credited with its development. And essentially that is why Darwin is remembered more than Wallace. But one of the key messages to take away from this wasn't that he simply put forward a hypothesis, he tested that hypothesis, and through an extensive amount of evidence, he identified a plausible scientific mechanism for evolution. However, he never called it evolution. Throughout his entire Origin of Species book, he referred to descent with modification, which was the title of his first essay. And essentially, descent with modification revolves around the tendency in organic beings descended from the same stock to diverge in character as they become modified. Now, this encompassed descent with modification by natural selection and was based on three broader observations: the unity of life, the diversity of life, and the adaptation of life. Essentially, the unity of life was attributed to a single common ancestor that lived in the ancient past and gave rise to all subsequent organisms. The descendants of this ancestral organism spread across the globe, occupying different habitats, and in order to survive in different habitats, they gradually accumulated a set of diverse modifications, allowing them to adapt to a specific way of life. And essentially, this was the entire basis of descent with modification. Descent relating to shared ancestry, and modification relating to an accumulation of differences through evolutionary history, and that over time, this led to the rich diversity of life we see on Earth today. Now, this did lead to Darwin viewing life on Earth as a tree. The end of labelled branches on the tree relate to species that are present today, and the unlabelled branches relating to organisms which are missing, presumed to be extinct. And this allowed the forks of each branch to represent shared ancestry among those branches. So in Darwin's tree, we can see four distinct groups of organisms labelled A, B, C, and D. These are the species that are alive today, and they each have a common ancestor to species within that group, shown with a yellow dot. Now, one of the interesting aspects of this tree was that Darwin noticed that there were many morphological gaps in evolution between related species, and he attributed this to extinction events. And whilst Darwin didn't know this at the time, we have estimated that over 99% of all species that have ever lived on Earth are now in fact extinct. And so if we fast forward to today, we have developed this idea further and created what we call evolutionary trees, also known as phylogenetic trees, to group related species together based on shared characteristic or traits amongst the organisms. Now, these traits can include morphological features, genetic information, behaviour, or other observable characteristics. And by comparing these traits across different species, we can infer relationships that represent the most likely evolutionary history. Now, a key point to highlight with evolutionary trees is that they are what we call hypothesis-driven, which essentially means we state our hypothesis first and validate or refute it with evidence. Now, just as we saw with Darwin's drawing, each evolutionary tree has a root, which is a common ancestor that all other species within that tree originate from. Then, as we move through evolutionary history, there will be points in time where species differ from the ancestral population due to the emergence of different characteristics. This is where the lineages diverge or branch away from one another. Now each branch point creates a node on that tree that represents the last common ancestor for all of the descended lineages, with the terminals of each branch representing different species. And so if I was to ask you, are mammals more closely related to birds such as hawks and ostriches, or amphibians? Now remember, this relatedness has nothing to do with how close they are next to each other on the phylogenetic tree, as this tree has no real scaling to it, and it could even be written in a completely different way, yet still convey the same information. So what we are actually interested in is the last common ancestor between the two groups. And so if we work our way back from the mammals, they have a common ancestor with birds at node 3. And if we were to look at a second example of whether lizards are more closely related to ostriches or amphibians, the correct answer, which might seem odd, are the ostriches. And this is because they share a more recent common ancestor represented by node 4. And with that, we come to the end of this video. Hopefully you found the content useful, informative, and most importantly, easy to understand. Thanks for watching, and I hope you have a great day.